Math 98. This is a video for lesson 4.2, so our second to last new lesson of the semester. If we take a look at the first page, we are doing linear models and estimation again. This time we're talking about a context of looking at average per person milk consumption and how it's changed over time, as well as soft drink consumption and how that's changed over time. So I would invite you to maybe pause the video and read that the couple paragraphs there under the problem situation, talking about how milk and soft drink consumption has changed. And we're going to find out when those two things were equal. So if you want to pause it and read it for a minute, you can. I've pulled out the information we need from that paragraph up here. So in 1950, on average, people drank 36.4 gallons of milk per year. By 2000, that had dropped to 22.6 gallons per year. On average, right? Not every person drinks exactly that much, but if we averaged it out. Soft drinks in 1950, people drank an average of 10.8 gallons per year. In 2000, that had risen way up to 49.3 gallons per year. Alright, so we are going to be building linear models again, building equations to model how the soft drink and milk consumption has changed over time. And what we're going to need to talk about is slope again. We talked about this a little bit in section 4.1, but we want to talk again about slope. So what I usually have you think about when you're thinking about slope are some staircases. So imagine you go in an old house, maybe your grandparents' house or something, and you go up into the attic. Most of the time, attic stairs are going to be really steep, right? They might even be kind of hard to walk on because they're so steep, and they're tall. So here are my attic stairs. Now, think also about if you go to a building that's like a big museum or some big office building, and maybe out front there are some wide stairs out front, right? Just kind of a whole fancy little stairway that goes up to the front door. So if we look at these two, this one is clearly steeper than this one. And what is it about this staircase that makes it steeper? Well, what makes it steeper is that for every single step, I have to step higher for a certain width, right? So for my attic stairs, my feet are going to have to really step up high. For these, I just have to take little steps, but they're wider. So the steepness depends on if I'm going from one point to the next, or you could think about the top of the stair too, how high do I have to go and how wide do I have to go. This one, the height is much smaller compared to the width than this one is. So that's really what slope is. We talked yesterday or the other day about having rise over run as one way to explain slope. We also can talk about it as change in the y value, which remember is vertical, or your height, over change in the x value, which is horizontal. So again, how much higher each stair is compared to how wide it is. All right, so another way we can figure out slope. These are kind of just sort of general expressions about slope. But we do have a formula also. So our formula is going to be y2 minus y1 over x2 minus x1. So these 1s and 2s right here are not exponents. It's nothing, we're not multiplying anything by 2, they're just labels. So in order to find my slope, I need 2 points. And when we have points on a graph, we know that the first value is x, the second value is y. So I have 2 points. I want to keep them separate in my head so I know what's what. I'm going to call this one x1, y1, and I'm going to call this one x2, y2, just to label them. It doesn't matter which I call which, and that's where these come from. If you don't want to, if the 2's and 1's are getting you a little confused, you really can think about it as y minus y over x minus x. The only thing we have to do is when we subtract, we have to make sure we go in the same direction for the top as we do for the bottom, and we'll talk about that in just a minute. So remember, another word for slope is rate of change. It's how fast one of those things is changing compared to the other. So on a graph, it's the vertical change and the horizontal change. In a problem like this, those each have a context. So we're going to take our information and make points out of it. Okay, if you look at number 1, it says to find the slopes or the rate of change for both the milk consumption and the soft drink consumption. So that's 2 different problems we have to do. So let's look at milk first. Okay, so if I want to find the slope, I need 2 points to work with. Okay, and a point is an ordered pair. It's 2 pieces of information that go together. So, one piece of information has to do with what was happening in 1950. And in our case, my x value is going to be my year. Your x value is always your independent variable. So if you can give me any year you want, it's independent, and then based on that year, the number of gallons depends on what year you gave me. So this right here is number of gallons. Okay, so my year is going to go in x. So in 1950, average consumption per person was 36.4 gallons. Okay, so here's 1 point because those 2 things go together. What's another point for milk? Well, take a minute and see if you can use the information to write out the other piece of information that we know for milk. And then you can look up here and see if it matches mine. Okay, so in 1950, the per person consumption per year was 36.4. In 2000, it was 22.6 gallons. So now I want to find the slope. So I need to subtract the y's on top and subtract the x's on the bottom. And this is where I'm saying you have to use the same order. So if I do 36.4 minus 22.6 in the numerator, then I have to go in that same order, top minus bottom, for the denominator. Or if I were to take 22.6 minus 36.4, that's fine, as long as I do the same order in the bottom. So I'm going to choose to do 36.4 minus 22.6 for my numerator. That means I have to go in the same order for the other values. 1950 minus 2000. Okay, now let's think about this for just a minute before we do those calculations. Milk consumption went down over time. Okay, so if we think back, this is more similar, of the 2 problems we did in lesson 4.1, this is more similar to the latte one, where we start out with a certain amount and it goes down over time. Okay, that's a negative rate of change, right? A negative slope, because as time goes on, my value is going down. Something is being subtracted. So we should not be surprised when we do this and we find that we have a negative slope here. So if I subtract the top, lost my calculator. If I subtract the top here, we will get 36.4 minus 22.6. We'll get 13.8 on the top. 1950 minus 2000 is negative 50. It's okay to have a negative there because that is what's going to give us our negative slope, right? So our slope here, and it asked us to round it to 3 decimal places, but that's actually all that comes up anyway, is negative 276 thousandths. So this is the slope for milk. Now, if we want to think about slope or a rate of change, really we want to think about two parts to that. How is this thing comparing to this thing? So let's think about the units here. What is going down? Well, it's the number of gallons. So our consumption is going down 0.276 gallons per year. Okay, that's how our graph, or our information is changing over time for the milk consumption. Okay, let's look at soft drinks now, or soda. So I want you to go ahead and try this on your own, okay? You can first use the soft drink information to write 2 points. And then if you want, you can come back to the video and check that those are right. And then you're going to use this formula to find the rate of change for the soda. Okay. So, using that same formula, I'm just going to put it up here so there's a little more space here without having to erase anything. Same idea. So if I do 10.8 minus 49.3, and again, you can go with either order you want. If you want to do 2 minus 1, 1 minus, it doesn't matter, okay, as long as you're consistent. So I'm going to have that on top. Then I'm going to have 1950 minus 2000 on the bottom. So 10.8 minus 49.3 is going to be negative 38.5. And on the bottom, I also have negative 50. So let's look at what we have there for a minute. I have a negative on the top and a negative on the bottom. When I take a negative and divide it by a negative, I'm going to have a positive. I'm going to end up with positive 0.77. Does it make sense that we have a positive slope here, or a positive rate of change? Well, positive means something's going up. So again, this is how many gallons per year. This time, instead of going down a certain amount, because it's positive, we're going up. And that does make sense because your soft drink consumption went up a lot during that time. It went up. So every year it went up. That's what we're assuming, right? Sort of a simplification possibly, but that's what we're assuming with our data here. So this went up. People on average throughout this 50 years drank 3/4 of a gallon more soft drinks than they had the year before, every year. Okay. So we have the two slopes. So now in number 2, this seems unrelated, but it's not. It's kind of working toward what we're getting toward to write our models. Number 2 just says, all right, if t is 0 in 1950, if time is 0 in 1950, what does t equal in 2000? Okay, so think about that for a minute. T is going to be a value that has to do with what year it is, without us having to actually work with the year 1950 or 2000. Our data only goes from 1950 to 2000, so we don't really care about, this might not work for years below that or above that, after that, okay? In 1800, maybe they didn't drink as many soft drinks because they weren't as available or something. So we were just looking at that time period. So we're going to say 1950 is year 0. If that's the case, then what would I call the year 2000? All right, I'm going to have to stop the video before it gets too long, and we'll pick this back up in just a minute.